Hello guys, welcome to this practical course on STAAD Pro software. In this lecture, I will show you some of the thumb rules that you can follow for preliminary beam and column sizing. Now coming to the beam sizing, you can consider the effective depth of the beam as span of the beam divided by 12 to 15. So for example, if your span of the beam is 15 feet, then you can consider an effective depth of around 1 feet, which is approximately 300 mm. Once you know the effective depth of the beam, you can easily calculate the overall depth of the beam. Please note here that the overall depth of the beam is including slab thickness as shown in this figure. Now, width of the beam can be considered as equal to width of the wall. We generally consider width of the beam as 230 mm, which is approximately 9 inches. You can consider size of the plinth beam as 230 mm by 300 mm or 230 mm by 375 mm for spans up to 15 feet and 230 mm by 450 mm for spans more than 15 feet. You may have noticed that the size of the plinth beams comes out to be very less as compared to the size of the beams at typical floor level. This is because the plinth beams which are supporting the plinth slab, basically the plinth slab is resting on the soil, hence we do not apply any load on this slab at the plinth level as well as the plinth beams. Hence, the size of the plinth beams will be much less. Now coming to the size of the columns, if your building is up to G+2 floors and the span of the beam is around 16 feet, then you can consider 9 inch by 12 inch columns at the periphery of the plot and 9 inch by 15 inch columns at the center. Obviously, the size of the column at the center will be higher because the loads will be coming from all the 4 slabs at the center. Now coming to the buildings from G+3 to G+4 floors and spans up to 16 feet, you may consider 9 inch by 15 inch columns at the periphery and 9 inch by 15 inch columns at the center. If your building is from G+5 to G+9 floors, you can consider 9 inch by 15 inch columns at the periphery for spans up to 10 feet to 12 feet and 9 inch by 18 inch columns for spans up to 16 feet and 12 inch by 18 inch columns for spans more than 16 feet. We will use these thumb rules for our live project. Now please note here that as per IS 13920-2016 code for zones 3, 4 and 5, the minimum width of the column is equal to 300 mm or 20 times of dB, whichever is larger. So whatever the sizes that I have mentioned over here, in this the width should be replaced by the minimum value, which can be calculated from this clause. And as per IS 456-2000, we know that the maximum percentage of longitudinal reinforcement in columns should not exceed 4%. However, for an economical design, we will consider the maximum percentage of reinforcement as 2.5%. So now coming to our, as you can see, this is the corner part of this building. So at this corner we will provide a smaller size. Similarly, at this corner of the building we will provide a smaller size. So here I have assumed that the size of this column is around 300 mm by 375 mm. So what you will do is that you will type REC command in AutoCAD and you will provide size of 1 feet by 1 feet 3 inch, and simply you will move this column at all the 4 corners of the building. Now coming to this portion, as you can see, the span of this portion is around 21 feet. So here we will need to provide a higher size of the column, and if you see the preliminary size for columns, you will see that we at least need here 300 mm by 600 size of the column. Hence we have provided 300 mm by 600 size of the column for this and this. Similarly, here also we have provided 300 by 600 size of the column as well, because this span is around 21 feet. Now coming to the periphery, here I have provided 300 mm by 450 mm, and here also I have provided 300 mm by 450 mm size of the column. However, here I will orient the column parallel to x axis, because that will not create any hindrance in opening my door of the bathroom. Similarly, here 300 by 450 mm size of the column. Here also we have provided 300 by 450 mm size of the column. Please note that you must provide 4 columns at each corner of the lift as well as at each corner of the staircase as shown in this. So once you have provided these sizes at the corners and at the periphery and at the central parts, what you will do is that right click anywhere in the AutoCAD, click on the quick select option, click on layer and select here columns and click on OK. As you can see, all columns in the column layer are selected. Now type CO command to copy these columns. Click anywhere and drag like this. Now we will draw the center line for the columns. So to create the center line, activate the line command by clicking on L and press enter. Now drag this center of this column and draw the line like this, passing through the center of these columns. Now I will change this line to the center line. So select the center line here. I will copy this center line. So I will type CO command and press enter. Now select this base point. Click here. At the center again, click here and click here as well. Similarly, again CO command, select the objects, again click here at the center of this column. We have created the horizontal center line. Now we will create the vertical center line as well. So again activate the line command by typing L and pressing enter. Click here and draw the line like this, passing through these columns. Now select this line, CO command and press enter. Copy this line at the center. So this is the way in which we will create the center line for the columns. You may notice that the center line for some of the columns is not passing exactly from the center of the columns, but that is okay. A deviation of around 2 to 3 inches might be okay. So now we have prepared the center line for the columns. In the next video we will start our modeling in the STAAD Pro software. So guys, that's all for this video. You can like, share and subscribe to my channel so you don't miss any future update for this practical course. See you in the next video.